So sorry about that, I got cut off. What I was saying is that I was going to write out Kelvin in case you hadn't seen this unit before as a unit of temperature. And don't worry, eventually we're going to get to, when we discuss temperature, the units that you guys might know. But this is the base SI unit. Current has the base SI unit of an amp, ampere, okay? Luminous intensity is CD for candela. Okay, candela comes from the same, I assume, Latin or Greek, some language, the root word of candle. Okay, so that's a hint. It has to do with light and the intensity of light. An amount of substance is one that you've all heard of. Moles. It's written mole, and then the full word is mole. So they took the E off to make the abbreviation for the unit. Okay, so, and this one I want to come back to real quick so that you have a good understanding, but that's measurement of the amount of substance. All right, so the key thing about these is that they are mutually independent. So I'm going to put this in a box because this is the reason we call them base. Okay, this is what this word base means. It means that you can't take any one unit and write that unit in terms of the other ones, okay? So let's say you were trying to figure out what is a meter, okay? What do we mean by a meter? You can't say, oh, a meter is, 50 kilograms divided by 25 seconds raised to the power of 17 Kelvin. There's no combination of any of these other units that can give you a meter. You just have to define a meter. So these are mutually independent. I'm going to write that out. You cannot write one in terms of another. Okay? So these just have to be defined. These units are simply defined. So what I mean by defined is, and this is how it historically happened, is somebody said, oh, I've got a thing that's this long. How do I measure that? And they said, oh, I'd like to make a unit, let's say meter. It's not exactly how it went, right? A meter is newer. But I'm going to make a unit to measure this in. I'm going to say that this thing is 4.2 meters. And I'm now saying a meter is this long. Okay? This is what I'm deciding. This is what a meter is. That's the definition of a meter. This much length. Right here, between my hands. I'm just deciding it. That's what we have to do with these units. They're not derived from any underlying principles where we look deep into the universe and figure them out. Somebody just picked them. They just said, no, that much, that's a meter. For the second, they just said, about that long. That's what I want a second to be. That amount of time, that sounds good for a second. Okay? So these units are defined. Now, the question comes in, is there a better way or a worse way to define a unit? Okay? And how do we know that we've chosen the right way to define units? This guy wants a meter to be this long, and this guy says, I think a meter should be about that. Okay? And to some extent, that argument is still there. That argument will always be there as far as the arbitrarity of exactly what we define to be any given unit. However, there's a way that we can make these units a little more fundamental and a little less arbitrary. And that is, we link them to universal constants. So, a universal constant is something that's out there in nature, independent of humanity. If we just had the universe and humanity never existed, that thing would still be true. Okay, notice, we wouldn't have a meter being this long. If humanity never existed, there would be nobody around to decide, oh, that's what I'm going to make a meter. But these universal constants, these things that are true about the universe, those would still be there. And so the most fundamental way that we can define what is a meter is to say, let's link it to a universal constant. So I'm gonna write down a universal constant that a lot of you guys know, the speed of light. You may not know the value, but I mean you've heard of it. So speed of light, we use C, the symbol C, that's for historical reasons. And let me tell you what C is. C is 299,792,458 meters per second. Okay? The speed of light does not change. Since the universe came into existence, till this day, till this very second that you're watching this, that's the speed of light. It's always that speed. And this label that we've attached to it has things we've made up. It has meters and it has seconds, and these are things we've decided. This is why this number is so weird, because we've decided to pick these, and then we've gone back and said this universal unchanging thing is this amount of these that we picked. So what we can do is we can flip the script. If I take, this is 1 meter over 1 second, that's what the unit means here. If I take and multiply both sides by seconds, so I'm going to get rid of this s here, I'm going to multiply it, it cancels on this side, and here we get it on this side. 1 second, I'll write this 1 second, times the speed of light is that many meters. We're still good, okay? Now, I'm going to take this number and divide both sides by it. So I'll rewrite this. 1 second divided by this number, and then on this side it cancels. It was in the top, I divided by it, and all that we're left with is the 1 meter. So I've just rearranged this equation. Now see what we have. What we have, oh, and then there's a times c. Okay, the c is still there. We have 1 meter defined as a fraction 299,792,485th of a second times the speed of light, an unchanging constant. This thing is more fundamental than our definitions. And so I hope you're wrapping your head around this, that now we've defined a meter. Instead of just randomly choosing it to be something that could change, could not, if Earth blew up, we would lose track of it. Where's the meter? What do we use to measure anymore? Okay? Now, we can measure it in terms of this C, an alien civilization. If we gave them this number, this is our weird number that came from historical reasons. Okay, back in history, they picked it out, and this long, and so we got this weird number. But if we gave them this, they would be able to measure C for themselves. And so now a meter is defined independently of the existence of the human race. Okay? Now, there's a big milestone that happened in 2019, just last year. And that milestone is that all base units are now defined in terms of these universal constants. All 7 of them. So just like we talked about for the meter, the story's a little more crazy for some of the rest of these 6 units, but every single one of these units in this list, as of last year, now is not directly linked to some human arbitrarily going that much. Okay? They're tied to these universal constants of nature, things like C, the speed of light, other things that are fundamental to our universe. Okay? And this, I don't know, this is a big milestone for me. When I was a student, this wasn't the case. We still had this weird arbitrarity, and it bugged me a lot. And so I was excited when this was announced in 2019. I've been following it for years up until then. Okay? So that's the story. Now, I'm going to look at this board, and I want to talk about the elephant in the room, which is the fact that these are SI units, and I've been talking about a meter really intensely, but what about feet? What about yards? So we've got this dichotomy. I'm going to write out standard international, that's what the SI units are, standard international units, versus what are called imperial units. Called imperial for historical reasons, okay? So these are the units you're used to. If you're worried about feet and yards, those are imperial units. The imperial units are also called standard units here in the US. Everywhere else, standard international, that's standard. In the US, we call them standard. This also is called metric, okay? The US is actually the only civilized country that still uses these. Some of you might know that. And so, for that reason, some people sometimes nickname them barbaric, because everywhere else in the world is civilized. So our department head here, Sean, likes to call them civilized and barbaric. You might hear me use that terminology. Okay, it's just that these are, for several reasons, a lot harder to work with, and so there is a reason why the rest of the world has adopted the civilized standard international units. Okay. Now, you might be saying, why can't we just use these? These are just as good, and yeah, they're just as good in practice to use or whatever. But you have to understand that all of these units are defined in terms of these units, okay? So if you want to know what a foot is, and you're like, oh, a foot's that much. Well, what is a foot? Oh, it's that much, I just measured it. But what really is it? Well, what it really is about 0.3048. This is a decimal expansion that goes on forever. Meters. So a foot, our American unit here that we like so much, it's just defined to be that many meters. And that's how it is for every unit. Every US unit that differentiates itself from the metric system, its definition at its core is just, it's a certain amount of the other system. So one more example. 1 pound is about 0.4536 kilograms. Okay, that's all a pound is. A pound is just, we're being obstinate. We're saying, nah, 1 kilogram, I don't want to deal with 1 kilogram. I want to deal with 0.4536 repeating kilograms. That's what I'd rather deal with, a pound. Okay, but that's all they are. They're defined in terms of that. So, but we're gonna deal with imperial soon enough. Okay, so for today, that's all I'm going to say about imperial units, because they're more messy, and I don't want to deal with them today yet. Okay, so these are base units. Now I want to briefly mention about derived units. This is where we answer your questions about what about the quantity that I thought of that you don't have a unit for up there. And this is where you'll start to see what I mean about these being mutually independent, okay? So for example, remember that our unit of length, these brackets are going to denote the unit of something. So I'm saying length, and then the unit of length equals the meter. That's defined by SI. But suppose, so like I have this piece of paper right here, okay? So I want to know what the area of this piece of paper is. I can't say, well, the area is 11 inches. 11 inches, that's the area of it. No, that's the length of it, one direction, but I'm asking about a surface. I'm asking about the area, so I need a unit for that. So what are the units of area? Well, we just take the unit of length and we square it. because we've got a length this way and we've got a length this way. And so we multiply them, so we get 2 units of length, making a unit of area. And volume is the same, but we have 3 directions, so it's meters cubed. So notice how area and volume are not base units. That's because they're not mutually independent. They can be written in terms of another. Okay, I'm writing these 2 in terms of another. That's what makes them derived. Oh, I forgot to say we're talking about derived units. That's this subheading, derived units. Okay, another example of a derived unit would be how fast is something going? And for now I'm going to call that speed. What's the unit to measure speed? It's not on that list because it's not base. It is derived from the meter and the second. So you take 1 meter, a base unit, divide it by 1 second, another base unit. So now you've made a new unit, but it's not independent. I can write it in terms of those units. Okay, so these units combine in various ways to make every other unit you've ever heard of. Okay, I promise. So what do I mean? So for example, I'm just gonna make something up. Let's combine those in a crazy way. I want to cube meters, multiply it by a Kelvin, multiply it by an amp squared. I want to divide by seconds to the 125th, and I want to throw in a candela there on the bottom. Okay, I've made this weird, crazy thing. That's some sort of unit. Okay, I've just taken and combined all those base units, and I've made myself a new unit. Now this isn't practical for anything, but it's in principle a unit. So some of the ones that are practical have nicknames. So what do I mean by that? So this is a unit, but it's not practical. So I'm just going to kind of do that because we're not going to actually use something like that. Something we do use are units of energy. We talked about energy last lecture. The units of energy are kilograms times meters squared divided by seconds squared. Okay? This combination of those base units gives us a derived unit, and that happens to describe an amount of energy. There's a nickname for it. The nickname is a joule. Okay? And we denote it with just writing a J, joule, J. Okay? That's the symbol that we use, but this symbol isn't a base unit in and of itself. It's just a nickname that we're using to refer to this thing, this combination of base units. Okay, so that's the difference between these base units and these nicknamed units or derived units. Another example, if I take, I better get this right. Yeah, okay. 86,400 seconds, that's got a nickname to it. Day. A day. Okay? The day is a nickname. The actual unit there is the second. And I'm just taking a large amount of them, and it's got a nickname which we call a day. Alright? Now, here's where I wanted to talk real quick at the end about the mole, the measurement for, here, I'll bring this back down so that you can see it. Amount of substance right here. This is what we use to count. Believe it or not, we need a base SI unit to count, right? We want to cover all our bases. We've got time, we got meters, and we go, okay, well, I just want to count things. I have a bag of jelly beans here. So in my bag of jelly beans, maybe I have 24 jelly beans or whatever. Jelly bean is a unit. It's an amount of something. I have 24 of them, and the unit is jelly bean. Okay, I know this is a silly example, but it's got a point. That unit jelly bean is a nickname. And it's a nickname for, so let me write it down here. some crazy number of moles. So this is a huge number, okay? This is a crazy number. But just like we had so many seconds and we nicknamed it a day, we have so many crazy moles, and we're gonna call that a jelly bean, okay? So even counting units. I have 8 students right now in this class. So student is a nicknamed unit. I can put it down here, student, and it's just a natural counting thing, and it also is gonna be some crazy number of moles. So mole is actually, and I know you've heard it from chemistry and it can get more confusing, but fundamentally what this thing mole is it's just a unit to count things. How much of this do I have? How many jelly beans, how many students? Okay, so I'm wrapping up here, but I want to give you a quick assignment for class on Wednesday, provided I can get this uploaded. I want you to bring to class a nickname of a unit. Some unit, something you've heard of, oh, this amount of this. Try and be as creative as possible so we don't have overlaps, and you got to use something that I haven't already talked about. And bring that to class with you, and what we're going to do is we're going to try to go backwards from it. And we're going to take your nickname that you bring, oh, I've heard of this as being units, and we're going to take that nickname and find out what the expression looks like in terms of a base SI unit. Okay? The next time we're going to talk a little bit about multiplying and dividing units when you're doing unit conversions in problems, and we're also going to do that little in class activity. So thank you guys.